Hello, geometry folks, and welcome to Arcs and Their Measures. You'll need your notes, a pen or a pencil, and a calculator, and we will get started. First, let's talk about some vocabulary, some arc vocabulary. First of all, if I have this circle, I have circle C. So this is circle C because the center is C. We have some stuff going on here. We have angle ACB. And then we have this little part that's called minor arc AB. A minor arc is any arc that has less than 180 degrees. Okay? And then if we look at the major arc is A through D going all the way to B. That's called a major arc because that is greater than 180 degrees. Okay? And then we would call this angle right here the central angle. Okay? Because it's the angle that we're looking for minor arc AB. A semicircle is an arc that has endpoints that make up the diameter. So if I were to look at the diameter of this circle, which would be D to A, okay, so that would be the diameter. The diameter then would give me an arc AD or DA. So I would have arc DA or AD. And that arc would be equal to 180 degrees because a full circle is 360. The diameter cuts it in half, which would mean I would have 180 degrees. All right, so if I give you a picture and ask you to identify which arcs are major, minor, or semicircles, hopefully we can figure that out. We know that a minor arc is an arc that's anything less than 180 degrees. A major arc is 180 degrees or greater, and a semicircle is always equal to 180 degrees. So if I look at arc AB, the measure of arc AB in degrees would be less than 180, therefore we would call it a minor arc. If I look at arc AB, and remember this is arc AB and then I go to C, okay, that would also be a minor arc because that would be less than 180 degrees. All right, if I did, let's go ahead and erase that now. If I did arc BDC, so B, so I'm going to start at B. It tells me to go through D and all the way to C. I would say that that's more than 180 degrees, so that would be a major arc. Okay, now if I were to look at BCD, get a different color here, BCD, because DB segment is the diameter is what cuts the circle in half, I would call that a semicircle because I would have exactly 180 degrees. All right, now that we've talked about minor arc, major arc, or semicircle, let's go ahead and talk about measures of arcs. So if I have this same circle that we were talking about, and we were talking about this minor arc AB, the central angle is 50 degrees, therefore the arc as well is 50 degrees. So the arc's measure in degrees would be the same as the central angle of the arc. Okay. If I wanted to talk about measure of ADB, so if I'm talking about the major arc here, ADB, that angle is 360 minus the minor arc, so the total degrees minus the minor arc, and it would equal 310, which would be the major arc. These two arcs together should add up to be 360. The measure of a minor arc is the same as the measure of its central angle. Okay, and that would be the case for a major arc as well. All right, let's do this example. Find the measure of each arc of circle C, where AB is the diameter. So AB is our diameter here. We want to know what the measure of DB is. So here is DB. That would be a minor arc. That minor arc would have the same measure as the central angle, so that would be 135 degrees. If I want to find the measure of DAB, I would have to go through A, so I'm going to start with D. Go through A and around to the B. Well, if this is 135, then everything that's left over would be what DAB represents. So if the whole circle is 360 and I subtract that minor arc 135, we would get 225 degrees would be the measure of DAB. Okay, now it's asking me to find the measure of ADB. So A through D all the way to B. Well, since AB is the diameter, then ADB would be the semicircle, which would be equal to 180 degrees. Okay. Can you tell me or find the measure of EFG? Okay, so if I want to find the measure of EFG, I first have to figure out where EFG is. So let's go ahead and see what we got here. Here's E through F to G. So that's the arc that I'm looking for. So the angle that I'm looking for is this angle. Well, first I'm going to look at this and I see that I have a complete circle, and a complete circle has 360 degrees, and it looks like the circle is being broken up into equal parts. This is an equal measure here, 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 here. So how many parts is it broken up into? 1, 2, 3, 4, 5, 6, 7, 8. If I divide that by 8, I get 45 degrees. So each one of these is 45 degrees. So if I want to go from EF to G, that arc would be 45 degrees and 45 degrees, which actually is going to turn this into a right angle. So the measure of EFG arc is actually 90 degrees, okay? Because we take 360 divided by the congruent parts and then take each part and add it to itself. Congruent circles. Congruent circles are circles with congruent radii. So if I have one circle and another circle and they both have 5 centimeters as their radius, then they would be considered congruent circles. Congruent arcs are arcs with the same measure. Now the only time you can have arcs with the same measure are arcs that have the same measure in the same circle. So if you have exactly the same circle and they have the same measure, they would be congruent arcs. So in the last slide that we just did, those two arcs, if I did EF and FG, they would each be congruent arcs. And if I added them together, I could get the two arcs together made 90. The other way you can have congruent arcs is if you have congruent circles. Now, in order to be a congruent circle, you have to have congruent radius, or radii. That's plural for the radius. Okay, so let's take a look at three possibilities here, and let's determine whether or not these arcs CD and EF would be congruent. And let's see if we can explain why or why not. So here we go. CD, arc CD, so we have CD here, and EF. Are they congruent? They are. They're in the same circle, and they both have 45 degrees. So yes, they are congruent. Okay, let's look at the next one. CD and EF. Okay, in order for the arcs to be congruent, they have to be the same measure in the same circle. Well, they're not the same circle because we have two different circles here. We have circle Q, inside circle Q, and then we have the outside circle Q. Okay, so they're not the same circle. And then the only other way that congruent arcs can be congruent is if they are the exact same circle, so congruent circles. So they have the same radii. Well, if I look at the inside circle, the radius does not equal the radius of the outside circle. Therefore, these two arcs are not congruent because the circles are not congruent and they're not the same circle. All right, now let's look at the last one. Would CD be congruent to EF? Okay, well, there's a possibility here because at least we have the same circle. Now we got to decide what the angles would be for CD and EF. I have 360 degrees here, and I have an angle here, and I have a radius, and I have a radius, and I have another radius, and I have another angle, and I have another radius. And these angles would be called vertical angles. And so I have side angles, sides. These angles would be the same. And if these angles would be the same, these arcs will be the same. Therefore, yes, they are congruent. All right, that's all I have for arcs and their measures. Thank you for taking good notes, and we will be back to practice it tomorrow.